Hey guys, so today we are going to learn about geometric sequences. We'll do a worksheet about it tomorrow in class. So first thing we want to do is identify our learning target. So it says I can find any term in a geometric sequence, and I can write the explicit formula for a geometric sequence. So pretty similar to what we were doing with arithmetic sequences. Alright, so first thing we need to identify some definitions so we can get through this part. Geometric sequence. So that is a sequence in which the ratio between consecutive terms is constant. A common ratio, which we're going to use notation R, which should sound familiar, that's kind of like our common difference, like D, the pattern. But in this case, it's the common ratio between consecutive terms. And what that means is that it's going to be multiplication. We aren't going to use division for any of our patterns. So everything we write will be in terms of multiplying. So if you need to pause the video to get these written down, go ahead and do so. Okay, finding the common ratio. So we've got this pattern, we need to know how to be able to identify it. So here's our example. We've got 50, 25, 12.5, 6.25, and then you can see a dot, dot, dot behind my screen. So we need to be able to solve for R. So off the bat, you should be able to see kind of what's going on here. This is a pretty noticeable pattern. You see here, we divide by 2. We divide by 2. But like I said before, we aren't going to be using division for any pattern. So we need to know how to express that as multiplication. If you're a little unsure, the way we do it is the same way we did it for arithmetic. It's just instead of subtracting this minus this, we are going to divide. So pick any two consecutive terms. I'm going to pick these two. And I'm going to divide 12.5 by 25. Remember, consecutive means right next to each other. So when we do that, you get 1/2. If you're a little unsure, remember you can always go type it into your calculator, get the decimal, and hit math frac. So moving right along, our explicit formula. So our new explicit formula, because it's a different type of pattern, so we can't use what we've been using. It's still going to be a sub n, remember that means any term, equals a sub 1 times r, so our common ratio, to the n minus 1 power. So if you need to pause the video to get down that information, go ahead and do so. Okay, so I am going to give you a couple practice problems really quick, just identifying, is this geometric or not? So go ahead and pause the video and decide yes or no for 1, 2, and 3. All right, welcome back. So we need to look at this. So the first one, you see 3, 4, 5, 6, 7. Well, 3 to 4, you go up 1, 4 to 5, up 1, 6, up 1, up 1. But it's by addition, okay? So since it's addition, it can't be geometric. So we should have said no for that one. That's actually an arithmetic sequence. All right, number 2, 40, 20, 10, 5. So you see here, multiply by 1/2, multiply by 1/2, multiply by 1/2. So we should have said yes for that one. And then 3, a little harder to see. If you were confused, remember you can divide negative 10 by 5, so negative 2. So 5 times negative 2, negative 10. Negative 10 times negative 2, 20. 20 times negative 2, negative 40. So you should have said yes for number 3 as well. So make sure if you're confused on that, you come in tomorrow ready to ask questions. Okay, moving on to applying the explicit formula. So we are going to look at these 3 problems. You see them on our screen here. I want you to go ahead and pause the video and try to work through these as best as you can. Alright, welcome back. Hopefully you had success with these problems. If not, we're going to work through them and see. If you're still confused, remember, come in tomorrow, ready to ask questions. So question 1, find the 20th term when a sub 1 equals 7 and r equals -2. So remember, n is your number of terms. So we know that we're looking for the 20th term, so that means a sub 20. When a sub 1 is 7, so our explicit formula tells us to do a sub 1 times r, very important to put that in parentheses, to the n minus 1 power. And we already said n is 20. So 20 minus 1. And I need to get my calculator. 1 second. All right, so remember, when we're doing these problems, order of operations, we have to do this one first. So you should have done -2 in parentheses to the 19th power, and you get a really big number, -524,288 times 7. So you should have got -3,670,016. So a big number, and we'll talk about that more tomorrow, why they get so big. All right, question 2. Find the 12th term of the geometric sequence, and then you're given the list of numbers. So if you couldn't read that, it was 3, -6, 12, -24, 48. So first thing we need to do, I know I need to use this formula. Identify what you know. So I know that there are, I know that the first term is 3 because that's just what's written first. So I know 3 goes here. R is my pattern. So how did I get from 3 to -6? -6 to 12, so on and so forth. Remember, if you're confused, pick 2 consecutive terms and divide right by left. So you get -2. So again, it's not always going to be -2, just a coincidence. It's telling us to find the 12th term, so that means that we're doing 12 minus 1, and that should give us a sub 12. So you go in your calculator, -2 raised to the 11th power times 3. And we should have got -6,144. All right, question 3. Last one. Which term in the sequence is equal to -3,645? So again, if you couldn't read that sequence, I don't know how it pops up on the video. So it's -5, -15, -45, -135, ... So we're trying to figure out which a sub what is equal to -3,645. So that's solving for n, okay? So we know -3,645 is equal to our first term times our pattern, so going from -5 to -15, that's multiplying by 3, to the n minus 1. All right, so first thing we need to do is we need to move the -5. So we do -3,645 divided by -5. And we get 729 equals 3 to the n minus 1. So for now, we'll get into this lesson in a little while. We're going to guess and check. So we need to see what power we need to raise 3 to get 729. So let's start with 4. So 3 to the 4th power, 81. Doesn't work. So try higher. 3 to the 5th. Doesn't work. 3 to the 6th. 729. So I know that this needs to be 6 because 3 to the 6th power is 729. So that means n minus 1 has to equal 6. Add your 1, so n equals 7. All right, so tomorrow's worksheet will be over identifying is it geometric or not. You will have to find the common ratio, and then you'll use the explicit formula to find a bunch of different terms. All right, so come in tomorrow ready to ask questions, ready to work.